So this is the last lecture of today afternoon. I hope that keep you awake. Or I'm not sure whether it's too boring to you or not, but there will be some mathematics, but no worry, no calculation, no test today, but there could be some mathematics because the topic just now in between more or less on the concept principle, isn't it? Not much about mathematics. Now I will come back to this road safety engineering. So maybe I first ask you a question. Say 1, 2, 3, 4, 5, 6, 6 number. Hey, how about I ask you to pick up one number? 1, 2, 3, 4, 5, 6. 2. Okay, 2. So if I ask you to fold a die, you know what is a die, isn't it? That have 6 faces. Yes, isn't it? How to say in Korean? 추차윈. Yes, if I ask you to pay a 추차윈, just now you say what a number? 2, isn't it? 추차윈. Hey, how about I ask you to pay a 추차윈? Could you win him? What do you think? 2. Just now he said 2. What do you think? Could you get a number that if I ask you to fold a 추차윈, could you get a number that is greater than what he said? What do you think? Just now he mentioned 2. Yes, you think yes, isn't it? Because it has a higher chance, yes. Isn't it? So if you pick up a number, say 5, how about 5? Now, do you think you have confidence to get a greater number? 5. Do you know what I'm asking?
I think she understands.
Yeah? What do you think now? If now the number is 5, do you think 추차윈 you can get a number that is greater than this? Probably not. Why do you think it's probably not?
Because the chance is lower.
The chance is lower, isn't it? The chance is lower. That because the average is what? 3.5. 3.5, isn't it? This is the concept about mean, isn't it? 3.5. If I ask the whole class to pay the 추차윈, the average is 3.5, isn't it? Isn't it? So now how about professor? He fold a die 6. Do you think you can win? Certainly, you don't think that you can win, isn't it? Because this number 6 is higher than the average. It's difficult to get a number that could be greater than 6, isn't it? Lower chance. This is something that I'm going to talk about in safety, about statistics. When we do the evaluation, there could be some puzzling issue that we call regression to mean. Next, at the end, I will tell you why I asked you such a question. So, this part I separate into 2 components. The first component is about what we say accident reduction plan. So, we solve a problem that Professor Zhang asked in the beginning, quantitative thing. When we pick up a location, say, in Seoul, there are many intersections, isn't it? Which intersection should I pick up to do improvement? This is something that I will take care in this accident reduction plan in the first part. And in the second part, I will talk about some interesting issue about analysis. Before and after analysis. What does it mean by before and after? For example, there is a pedestrian crossing that is very dangerous. Now I put up a signal. I want to know whether it's good or not. So what I do would be that, say, how about after 1 month, I count how many people may be involved in accident. Isn't it? This is what we mean by before after analysis. But there could be some issues. So this is something that I would like to talk about in second part. First talk about this. Traffic accident. Say if there are 100 traffic accidents, we know that 85% or here I say 94% because of the human error. That is why very often we emphasize on human behavior. Basically, it's because 94% come from human factor. Hey, you see here, there is some overlap. What does it mean? Is the joint force because of different kind of the factor. So, for example, world environment could contribute to about 19 to 29%. Some of the accident could be because of the joint force because of the poor world environment and also human factor. What does it mean? Say, for example, under the windy situation, it's about the environment, isn't it? So in this situation, maybe I'm not quite careful enough, or I do not use an appropriate speed, then there could be an accident. Then this could be a joint force because of the world user and the world environment. Anyway, I just want to emphasize that why many different kind of road safety measures or policy focus on the human behavior. Basically, it's because of this. We classify the factor or reason into 3 different types: human, world environment, and the vehicle. I say vehicle design is not something that we take care. It's the mechanical engineering. They look at the vehicle design. As a civil engineer, we look at world environment and also the human behavior. So that is why we need to do a lot of things. In the first lecture, I talked about this road safety audit. Basically, it's about, say, how can we help the driver or help different kind of road users. They can use the road more safer. And we also have many statistical models that try to figure out the distributions of the accident and try to find out the relationship between different kind of factors. That is why we can have that 94% result. Basically, it's come from the statistical model. So now we come to the thing that say, how can we pick up the location that we know there should be, we should treat them or not? Here come to several types of what we call accident reduction plan. So the first thing, site plan. So imagine this is a map of a particular area. These dots, red dots, representing the locations of the accident. So this dot, you see there are some smaller one, there are some bigger one. What does they mean? They are actually referring to the number of accidents. So it's quite sensible, isn't it? If we have the accident data from the police, they record the location, isn't it? Nowadays, we have many different types of the map tools that we can actually put the locations of all the accidents into the map and visualize them. This is a process of visualizations. We call this a GIS approach. So it's very easy for us to find out which location would have more accidents. So for example, we don't have much money. Usually the government would say that I don't have much money to do things for road safety, even though it's very important human life. Say, I only allowed you to do the work at 4 locations that is most dangerous. Then what would you do? Just like this diagram. I map all the locations of the accident and pick up the locations that have a bigger red circle, isn't it? This kind of situations that in this area, there are some ponds that have high accident. We call them as a site plan. Quite often we do it. In some countries, we call them black spot, or some people, they don't like use the term black, they call it hot. There is many accidents. So we call this kind of the accident reduction plan as site plan, that we take out several points of location. Usually this point of location will be some intersections. Quite often intersection is locations that have higher number of pedestrian accidents. Sometimes the distributions of the accident may not be that like this. I'm talking about may not be look like this, that there are several points that we find very big circle, many accidents. In some situations, maybe if I only look at the size of the circle, they may not be that big. If I ask you, say, in this diagram, pick up 4 locations that have bigger circle, it may be difficult. Why is it like this? Sometimes it could be the issues that the whole corridor, they have similar problem. So in some of the city or in some of the network, if the safety problem they occur along some corridor, it may be more suitable that we select this kind of the plan. So this site plan in this slide or whether we do the work plan will be depending on whether the safety problem is actually happen at a few locations only, or like this, some safety problem may be happen along some corridor. What does it mean by the problem may be happen along some corridor? Do you still remember the photo in the first lecture? I asked you 4 pictures, 4 kind of wall. Then maybe this kind of the wall, this kind of the network, the problem or the issue could be the design or how we manage the whole corridor. So for this kind of the situations, we will see that the accident may be more evenly distributed, and it's difficult for us to take out only a few points. So in these situations, if we say circle the corridor, it will be easier for us to find out that the corridor that we need to do something to do this. So this how we select the locations that we need to do something will be depending on what? Depending on the number of accidents, isn't it? For the site plan will be depending on the accident at a particular location. For the works plan would be it depending on how we say circle out all the corridor and count it. So nowadays with the GIS, with different type of the digital map, it will be easier for us to find out whether the problem are concentrated as a few locations only or they split through the whole corridor like this. In this situation, it would be more suitable if we do something to treat the whole corridor. So this is 2 different concepts, site plan, works plan. Sometimes even more difficult. Works plan, at least we can find that more accidents concentrated along some corridor. Sometimes we may find that maybe even worse, the accident evenly distributed in the whole area. In what situation we would have this? Those may be in the residential area. Maybe we will find that only if we circle out the whole district. Maybe in a city there are many different kinds of this area. We may be able to pick up an area compared to the nearby. They have higher accident. So this kind of situation, if the accident is even more evenly distributed around the city, we may need to do what we say area plan. So if the accident concentrated at a few locations only, usually there will be some intersection. It will be easier that we do something like changing the traffic signal, say changing the design of the crossing, red light running, then we do this. Sometimes it could be the design of the highway, say, if this is a highway that serves for the mobility, say, can we put some barrier, put some shoulder along the roadside, we can improve. If it is distributed like this, we say very dispersed, then maybe it could be because of we don't put very good traffic calming for some local area. So it depends on how the accidents are distributed. So choice of the plan, that is, are we going to do something that treat with the problem of our intersections? We use the site plan. If we are doing something that we are modifying the design of the motorway or some major corridor, then it will be a works plan. If it is an issue that can be resolved by traffic calming, it could be the area plan. So it depends on how the accidents are distributed. We call it spatial distributions. So nowadays it relies on whether we have the good data that, for example, police, do they have a good record about the locations? And this location record, is it easy for us to make it digitized and put it onto the map? So if we can actually visualize it, it will be easier for us to identify which type of the plan would be better. So this is the fundamental low mathematics, yes? So now I come on to the second part. So now we identify the locations, no matter whether it's site plan, works plan, or area plan. Anyway, now we identify the locations that have higher accident number. So we are going to treat them, isn't it? As I mentioned, we do some before and after analysis after we treat it. So do you still remember when I talk about the basic definitions? We have accident number. We also have accident rate. For accident rate, what do we need? Exposure, isn't it? What do you think? Which one should we use? Number of accident or accident rate when we pick up the locations that are more unsafe? How many of you think that we use number of accident? Say A, B, A or B. A is number of accident, B is accident rate. What do you think? When the government, they pick up the locations to do the treatment, do you think they use A or they use B? B. How many of you think A? You think A. What is the reasons?
I think the government will consider the accident cost.
Accident cost, yeah. Yes. Consider accident cost, we should use A, isn't it? Then what situation we should consider B?
The accident rates.
Mm-hmm.
I can't really think of an idea.
Yeah. Accident rates would be better for comparison because we do the comparison at the same base. From the perspective of the researcher, it's better to use B, isn't it, accident rates? But if you are a government officer, we would choose A. Why? I reduce more accident, more cost would be reduced. Then I may get a vote next time, isn't it? So if you are a government officer, you have potential then. We should choose A, isn't it? But you make a good answer that B and A both are good. So that is why I say here, actually we should consider both as a researcher, as an academic. We usually consider both, but normally for government, they only take A, number of accidents only. Exposure, there are many different types of exposure. In lecture 1, I only say 2 countries, we use populations. Some people also suggest using population density, isn't it? So for comparing different types of the world, we use different types of the exposure. Say for example, for intersection, if there are 2 intersections, we simply would use the traffic volume. We use the traffic volume. Sometimes we use the vehicle kilometer. Why do we use the vehicle kilometer? If it is the situation for works plan. If we want to compare the corridor, we use the vehicle kilometer. Say, 2 roads, they both have, say, AADT, maybe 10,000 vehicles. Both of them have 10,000 vehicles running along, but maybe this road is shorter, this road is longer. Which one have higher vehicle kilometer? This one would have higher vehicle kilometer because it's longer, isn't it? So if we are doing the analysis for comparing the safety of corridor, then the exposure should be vehicle kilometer. So that is why I say there is no unique answer for which kind of exposure should we take. Depends on the applications. If it is for comparing the country, comparing different areas, we use populations. Compare the intersection, we use the vehicle. Comparing the corridor, we use the vehicle kilometer. So we need to bear in mind, this exposure depends on our applications. One more issue. The exposure and the accident number, the relationship is not linear. The actual relationship between the exposure and the accident is actually in the shape of this in the red color. So what does it mean by the shape of the distribution is in the red color? That is meaning that if the exposure increased by 100%, what do you think is the accident number? Increased by more than 100% or less than? If it is like this, if the shape, so exposure go in this way, accident go in this way, and I told you the relationship is like this. What do you think? Exposure increased by 100%, then accident increased by more or less than 100%? Less than. You agree? Or less than or more than? Get lost. Okay. So anyway, less than is the meaning about that. Say this intersection, next year if there are 100% increase in traffic flow, accident number would not increase by 100%. It's quite sensible because more traffic, the speed will be lower. Then the accident number may not be increased in the same magnitude. So bear in mind, exposure and the accident, the relationship is non-linear. It's an issue when we are doing the comparison, and that is why we would think that both accident rates and number of accidents, we also need to look at. Say, for example, we have the curve for two different locations. Say, imagine site 1, site 2 is two intersections. And as I mentioned in last lecture, we can use some safety performance functions. So this red curve is actually a safety performance function that describes maybe the traffic volume, the relationship between the volume and the number of accidents. So intersection 2, the safety performance function is like this. So if the traffic volume is equal to this value, there are this number of accidents. Site 1, they have another safety performance functions. So you look at here, site 1 and site 2, if we look at the safety performance function, which one have more accident in general? 1 or 2? How about you put up a finger? If you think 1, you put up this. If you think 2 more accident, put up this. In general, site 1 or site 2, more accident. 1, 2, 3, put up your finger. Okay, I just want to test who is still listening. So, in general, so at the same level of exposure, isn't it all the time, site 1 have more accident. That is why I say, if we look at the safety performance function, site 1 should have more accident all of the time. If we are doing a comparison, say at the same level of exposure, so we draw a line here, isn't it? But you look at these two lines, what do you see? These two lines, if I say, for example, this line, if number of accidents divided by exposure, what would you have? Do you still remember basic definitions? Accident divided exposure is the accident rate, isn't it? So the slope of this straight line is actually what? The accident rate, isn't it? If I look at the accident rate, so intersection 2, it has this level of exposure. Accident rate is the slope of this line, isn't it? But intersection 1, it has more traffic, exposure higher. So the point is here, isn't it? And I draw a straight line here. Then this straight line, the slope is what? The accident rate of 1, isn't it? Now I ask you, you know that safety performance function is by the red line. You told me that site 1 more accident. But now if I compare the accident rate, only look at these two straight lines. Now I ask you another question. Site 1 or site 2? Higher accident rate? 1 or 2? Put up your finger. 2. Yes, so we see this tricky issue, isn't it? For the safety performance function, site 1 actually more accident all the time. But can you see this? Accident rate. Now, site 1 have lower accident rate, isn't it? I use an opposite way to describe. So, site 2 have a higher accident rate. So, we need to be careful. Even we have the accident rate, we have the accident number, we need to look at these functions, isn't it? So, it may not be enough here. We have accident number, I told you that it may not be enough. If you are a government officer, maybe they are not that clever enough, they only look at the number of votes. They only care about number. We are researchers, we also care about accident rates, isn't it? But if you are a safety researcher, we also look at the safety performance function. Then the story is different. So I just want to tell you that the beauty of the mathematics in safety analysis, that hey, you will know that safety, accident, exposure relationship is not linear. And it would create such an issue. If the exposure is actually different, we may get some misleading result observation only based on the accident rate. This is the first thing that I want to mention. Now I come on to the last part. It's already 5 o'clock. So I try to finish in 10 minutes maybe. Okay, so the last part already. So before and after analysis, I first talk about one interesting thing, traffic conflicts analysis. I think maybe Professor Kim may be interested in about this. Nowadays, we do quite a lot, smart mobility analysis. We say that we use CCTV, we use the computer vision image. Why we do this? One thing would be that nowadays we feel that accident number, accident record is not enough for our analysis. We try to use something that we call surrogate measure to analyze safety. Now I told you. What is the issue with accident number? In the first lecture, I say that rely on accident may not be that good because after the accident happens, we do something to treat it, it's a reaction. Not only this, statistically, accident rarely happen. Say for example, in Korea, we say that 1 year there are 2,000 people die on the road. But if you look at the whole country, these 2,000 fatalities, they are located in many different locations, isn't it? So if I ask you, the world outside this university, is it safe or not? Can you tell me based on accident number? If no, maybe in 10 years, you could not observe anyone die on the road. But actually, maybe it's not safe, isn't it? So this is the issue with the accident number, that we know that they rarely happen. They rarely happen. Even those for a intersection, we know that it is dangerous. Maybe in 1 year, may not be 1 people die at all. So if we wait for an accident to happen, it could be an issue. That is why now we come to a thing that we call conflicts. A conflicts. If we build something like this, if we build a distribution like this, imagine this representing all world users on the world, just like you. You are safe, isn't it? You are safe, isn't it? Will you cross the red line? No, isn't it? If I ask you, you will say no, isn't it? So we behave safely every day, so we won't encounter any accident. So this is our daily situation, isn't it? Accident only where very rarely happen, isn't it? Maybe we spend about 1 million minutes on the road. We will only encounter once. That is why accident is just like the tip here, isn't it? It's quite normal. Every day we go home safe, isn't it? It's difficult for us to observe accident. So now traffic engineer, they create another matrix they call conflicts. Conflicts is something that happens more frequently than accident. We know that accident is like this. If we say zoom it out, we see that fatal accident is only a very, very small part of this top one, isn't it? So now researchers, they try to observe something that we call conflicts on the road. Based on what? Based on video image. So what does it mean by traffic conflicts? Maybe quite often we may encounter this, say you are driving a car here, maybe someone suddenly cut in front of you, then you need to say slow down. Of course, you will not hit onto it, isn't it? You have good eyesight, you will stop, isn't it? But such a sudden stop, we call it a conflict. We call it a conflict, isn't it? So what we do here would be that we try to observe the conflicts on the road. We know that for one accident, there could be 40,000 of conflicts that happen on the road. This relationship is important. Say, if we put a CCTV at an intersection, maybe in 1 month, we could observe conflicts. It's important because we have more data. We need data, isn't it, as a researcher? So that is why we use conflicts to analyze safety. But what is the shortfall if we use these conflicts? We need time to take the video, isn't it? For accident record, government, police just provide it to us for free, isn't it? Conflicts, we need to do the observation ourselves. Who do the counting? Nowadays, we have computer vision. But in the old days, this conflicts was developed in about 40 years ago. At that time, the people only rely on manual observation. They hire a group of students like you, very good student, very dedicated, but sit in front of the TV to watch the video for many hours. When I was a student, I also did this. I take the video as the roundabout, and I sit there for about 100 hours to work out my first paper for traffic conflicts. It was the day that when we don't have computer visions. Traffic conflicts was developed in 40, 50 years ago. Nowadays it's good, we have computer visions. But anyway, I just want to say that traffic conflicts is a very good indicator for us to do the before-after analysis, because now we have something that have better sample size. We can do some statistical analysis. And some other issue, of course, we need to take into account the traffic flow. As I say, we need to use the accident rate, and we know that for accident rates, exposure, accident number, they are non-linear. So that is the issue that we need to take into account the variations of the traffic flow. And accident conflicts, we know that is some indicator that are commonly used. What else do we need to collect, or what kind of data do we need to collect? Sometimes we may also need to collect the traffic volume, speed, or deceleration. In what situation we may need? For example, traffic calming. Did you still remember traffic calming? I showed you the distribution graph. How do I come up with this? I measure the speed of the vehicle also. In the old days, it's difficult. I take a laser gun out and then shoot onto the car to get the speed. Nowadays, it's easier with the computer vision. We could also track the speed of the vehicle. So we need to use all this data. This is what we say some choice of the indicator that we commonly use in safety analysis. Traffic conflicts is good. In the old days, it takes quite a lot of effort, but nowadays it's easier. And the good thing would be that less observation time. If we rely on the accident, maybe we need to wait for 1, 2, or 3 years to wait until there are several accidents that come out. But with traffic conflicts, as I said, one accident, we have 40,000 conflicts. So after 1 month or after 3 months, we could already provide some results to tell the government, hey, say, this one is good, it's made effective because number of conflicts actually reduced. But what are the issues? Before that, I showed you a video again. This is something that we call active safety nowadays, already implemented in many cars. So do you still remember the first slide that I showed you? 94% of the accident is because of the human error. So all this vehicle technology nowadays is actually trying to mitigate the human error, the accident that is related to this. So now they actually implement on many different, for luxury cars, they already have this kind of technology, say detect the pedestrian, or when you do the lane change, provide you the warning. This is something that deal with the human error actually. So you see it can stop even for a container truck. So some interesting things just show you. So anyway, come back to the last part. So we do the evaluation, say at the intersection we put up say signal. Then maybe we have a choice. We can actually analyze the number of accidents, whether it's reduced, or we analyze the number of conflicts, whether it's reduced or not. How about let us come back to the case of using the traditional way, using the number of accidents. We come to an issue that, do you still remember the first questions we pay the what? The dice?
Choose how we.
Choose how we,
Yes.
yeah. You tell me that you choose 5, and then your classmates say, it's difficult to win. Get a number, isn't it? Come back to the questions. Do you still remember the site plan? There are many, many locations, isn't it? If we go back to this, so just like paying the true child dice, there are many, many payers here. Is it like a true child dice that some locations have 1 accident, some have 2, some have 3, 4, 5. Imagine it's the case of true child die. 1, 2, 3, 4, 5, 6. Average is what you tell me 3.5 or 3, isn't it? So, but I say that I take out some location to treat. They are what? They are some payer that pay the true child die, they get the 5, 6, isn't it? Isn't it? This is the rationale how we pick up the location, isn't it? Of course, this is the perspective of government. Those locations that we pick up are those that having more accident. But if I say accident is a process of paying the true child dice, this year I get 5. Say, for example, true child die, this time I get a 5. What do you think? I throw a true child die again. Do you think I would get more than 5 or less than 5? Which one would be easier? Less than 5 would be easier. So come back to this case. If this is true child die, these are those that get 6. What do you think? Next year, they pay a true child die again. They get 6, 5, 4. Which one would be easier? Get a 4, get a 3 would be easier, isn't it? So, without doing a treatment, the accident number would actually go down. Without doing anything, isn't it? So, I tell you, that is why I say in one slide, I say, accident rarely happen. One more thing, random. This number is random, just like paying the true child die. And especially when we choose the sites to do anything, we only pick up those having high accident. Just like I only pick up a few classmates of you that they get 6 in this true child die, and then I ask them to fold a dice again. And then I say, they must get a number that is lower than 6. Is it good? Isn't it? So you look back to this. If the number of accidents is a kind of random, it's quite easy to have this situation. This is a phenomenon that when we do this, before and after analysis, sometimes it's good. Some people would choose a control site. I would choose a control site because I do a treatment here. I do a control site, but even I choose a control site, but for the locations that you see pick up, it was because true child dice is you get a 6, isn't it? Without doing anything, it would certainly go down, isn't it? So we have a paradox in this. Even we do a control experiment, just like those biologists, chemists, they do a control experiment, but it is not enough. Those biologists, they do the experiment, they really randomly select the sample, isn't it? But are we randomly selecting the sample? The issue is how we pick up the sites that we do the investigation is not random. Basically, because they originally already have high number of accidents. So even we do this control site investigation, we still face the problem that naturally the accident number would go down. Not really because of you do something, it's because of the accident number is random. Because you pick up you intentionally pick up the site that have higher accident number, just like this phenomenon of this. So control site is a good idea for comparison. For government officers, they even don't do this. They don't do control sites. For traffic engineer, they select the control site, but it's not good enough as a safety researcher. We need to take into account just now this phenomenon. Hey, Dr. C, do you have a name for this phenomenon? Actually, yes. This phenomenon, we call it regression to mean. This regression to mean is not a new thing. Someone already tell us in more than 100 years ago, come from psychologists, that return to normal is very normal. Return to normal is a normal phenomenon that just like you pay twinkle die, isn't it? So we call this phenomenon regression to mean, especially for road safety, because we are not picking up the sites randomly. Basically, we intentionally pick up those sites that have higher accident. So I just want to tell you there is such a what we say regression to mean phenomenon. So I don't need to go through the words in detail. I just want to say this. Regression to mean basically is because of bias by selection. We select the sites that have high accident number, and so we have the regression to mean. So bias by selection, regression to mean are actually two items that come together because we have the bias when we select the site. We have this regression to mean issue. Even if we do this control site experiment, we cannot resolve this regression to mean issues. Only unless we have the statistic. We have a long-term statistic of all the locations and we build a safety performance function. We can identify this regression to mean issues. So this is the last thing that I would like. Oh, one more thing, risk compensation, also a very interesting issue. That was the one that, for example, when the vehicle manufacturer, they develop ABS. I'm not sure whether you know what is ABS. So they claim that ABS can actually improve the safety by a certain percentage, but afterwards they realized that the effect is not that significant. Why? Basically, it was because of the risk compensation. Say, I buy a car and I was told that there was ABS, so I drive what? I drive faster. So such a behavior, it offset the effectiveness of the ABS technology. Again, it's related to what? Perception. In lecture 1, I told you the perception. Perception would affect your behavior. This perception affect behavior could also be realized in safety analysis. That we see that there is an issue that we call risk compensation. So to sum up, I only want to mention two issues related to safety analysis. One is because we select the black site because there is a bias by selections and regressions to mean. So the effectiveness of some safety measures that we identify actually may be overestimated, may not be true. This one issue. Another is the risk compensation. When there is some new technology or new measures that are being implemented, the effectiveness is not something that we anticipate. It's because of the risk compensation. Human behavior, they do it more aggressively and offset the effect. This is the two issues that I would like to mention. So that's all for today. So hope that is not too long. It's 5:20. So any questions?
I was just wondering, most of the accidents happen because of human factors.
Mm-hmm.
So if there's going to be the penetration rate of the autonomous vehicles will increase eventually, I guess. So do you think that the factor could change to, shift it to more of the vehicle errors rather than the human factors?
Yes, the aims was actually this. Say we accept that there is limit for human capabilities. The concept is actually come from this. we could expect that many accidents can actually be avoided. But you see there's still some component come from vehicle, come from world environment. So how we can we make it zero? It's not possible. But we could try to resolve the part about human errors part.
One more question. So, if that happens, do you think that paradox can be solved? If the paradox is based on the human errors?
Do you still remember the exposure part?
Yeah.
Do you think more vehicle would be on the road? Say, for example, I'm not sure whether it's an issue in Korea. If you go to a area that don't have any parking, and if you own an autonomous vehicle, what would you do? How about you let the autonomous vehicle to go around when you get off? Could you do this? So originally, if human driver, you go to a location, say you go to the school, then you park the car. That's it, isn't it? If the school have no parking space, you have an autonomous vehicle. Then when you are attending the class in the afternoon, then you let the car to keep going around. Is it possible? It could be an issue in the future, but of course it's by our imaginations only. So this is what I want to say. We may induce more demand, induce more vehicle on the road, isn't it? This could also be an issue. If by statistics we know that exposure is also an issue, then do we also control the exposure? Yeah, this is the issue.
So I have one question. You showed 3 different levels, height, route, and
Yeah.
area. When you do the analysis, which levels are more influential on traffic safety?
I could say there could be an evolutions. For those countries, they are in the earlier stage in road safety development, say in Southeast Asia, maybe they usually are like the site plan. There are several locations that have higher. Then after that, we do some improvement. Then maybe the accident will be more evenly distributed. It become the route plan will be more significant. So there could be an evolutions. Just want to say the relationship between these three, they have a time evolutions.